Hello and welcome to another episode of Student Professor. Today our topic is going to be about bile. We're going to talk about the secretion of the bile, which is the production and the biosynthesis of the bile. We're going to talk about the mobilization, which means how does the bile move, and we are going to talk about the function and the regulation of the bile. Basically, it's an easy topic, but the most difficult part is to know to differentiate that the bile is basically a general term, okay? We always, when we think about the bile, we think, okay, it's made of bile salts and that's it. That's true, bile salts are the most important component of the bile. However, it is composed of different, other different components, okay? That is going to aim to its function, as we know in the lipid digestion. Okay, so first of all, let's speak about the function of the bile. Then we're going to talk about the components of the bile and then the circulation. The components of the bile are going to be bile acids, as I said before, and it composes almost half, the 50% of the total bile secretion. We have also phospholipids and cholesterol, 40%, bilirubin, which is the basically a kind of dye that is found inside the bile that makes it look yellow, and in some pathological conditions, when it gets out of the liver and the liver circulation, it is going to cause the yellowing of the skin and mainly the sclera. This is the so-called jaundice or icterus, and it's also going to be composed of electrolytes and water, of course, but in order to make it more thick, the gallbladder, it doesn't only store, but it's also going to reabsorb the water and those electrolytes in isoosmotic fashion, okay? We're going to talk about that later, and we also have the circulation of the bile. Where does it start from? Where does it end? And this is also the so-called enterohepatic circulation. Entero, the GI system, and hepatic is the liver. So it is a circulation in order to not to stress the liver so much in order to produce more bile. So it just uses the bile components that it has used before, okay? The most important keywords in this topic is, I would say they are three, okay? Emulsification, then we have something, the so-called micelles, and also the enterohepatic circulation and its function. How does it change with the production of cholecystokinin, which is the most important stimulator for the bile to be excreted, okay? So emulsification and micelles. And another one, let's add it, this is the amphipathic, okay? Amphipathic, it means that it has both an hydrophobic, it means that it hates water, so it's made of it's made of lipids, and we have the hydrophilic component, which is going to love water, so it's going to be soluble in the intestines, because as we know, the intestines are composed of mainly aqueous solution. That's why we need the lipids to be familiar and to love this environment, and that is the function of the bile here, okay? So what does emulsification mean exactly? Basically, emulsification is the first step for the digestion of the lipids, okay? So the lipids are going to reach, after they get to the stomach, they will reach the duodenum, okay? And when they reach the duodenum, they are going to still be hydrophobic. So they are going to be lipophilic, they are going to be composed of large masses, relatively large masses, that are very hard to absorb, okay? So let's imagine that we have our stomach here, not very important for us now. Here our duodenum, it's a bit bigger because that is the important part. And as we know, we have the sphincter of Oddi in the duodenum, and it is connected to the common bile duct that is composing the pancreatic duct, and then we have the hepatic duct that is going to give rise into the liver, and we also have the cystic duct, which is going to be in the gallbladder. Okay, so when bile is secreted here, before it was secreted, the lipids are going to be very large. They are very hard to absorb in the intestines. That's why the function of the bile comes in. Okay, the bile is going to basically, because especially the bile acids and it's called bile salts. Okay, it's salts and acids, bile salts. And as we know that the bile salts and the bile acids are amphipathic. That's why I said it's an important word to know. Amphipathic, it has both the components. That's why it is going to just bind and mix with our lipid components, our lipids, one of the nutrients that our body needs, and it is going to reach to the intestinal mucosa, and there it is going just to surround, that's emulsification, surrounding the lipid particles by a negatively charged compounds, which is basically the bile salts and the bile acids. They will be negatively charged, and in this way it is going to prevent these lipid particles to bind to each other's again and make each other's bigger. Okay, think about it as the oil, for example. Okay, the oil is not going to be soluble in water. Okay, and if we added bile to it, okay, if we added bile to the hydrophobic component, it is just going to surround it with negative charges. Repulsion is going to happen, and in this way they are going to stay smaller. So that is emulsification. The other one is the formation of micelles. Okay, what are micelles? Micelles, due to the fact that, again, the bile is amphipathic, it is composed, it's going to be forming micelles with these lipid particles, and it is going to cause the core, so the core of this micelle, which is a very small structure, mainly measured in nanometers. So if we compare the micelles with this structure here, this structure is way bigger than the micelles. The micelles are nanometers, these are micrometers. That's why the bile also is going to cause the micelles to form smaller structures that are, let's make them a bit bigger so you can see it here. It is going to have a core that is composed of lipids, okay? Basically all the lipids that we eat, for example, monoglycerides, fatty acids, phospholipids, cholesterol, whatever we eat is going to get in the core. That is our micelle, the core of the this ball-shaped kind of structure. And outside, in the outer surface, we are going to have the hydrophilic component. That's right, the hydrophilic component that is going to be soluble easier inside the intestinal lumen. Okay, so outside we are going to have, let's make it in green here, these components are going to be our hydrophilic, and this is our hydrophobic. So hydrophilic, phobic component. Both of these together are going to be the so-called amphipathic. Okay, so the idea is to make lipid soluble inside the intestinal lumen by two processes: the emulsification, which is basically, in chemistry, it is making two things that are not soluble with each other soluble. And the second process is the micelles formation, which is forming a periphery or an outer shell that is composed of hydrophilic components, and the core, which is composed of hydrophobic component, so that this is going to aid in the absorption of our lipids. Okay, so that is our first part. That is the function of the bile. It's important because it leads us to predict the structure. So